Alrighty, folks. All right, well, I'm really excited to be here. It's good to be in front of everybody here today. I've met a handful of you over the time that I've been popping into PI this term. To give you a little bit of an overview of what we're going to do today, I'm going to spend maybe 10, 15 minutes giving you a little bit of a lecture. I'm going to define what quantum ethics means, give you an example of what I mean when I talk about quantum ethics. But really, the majority of this session is going to be a group discussion where we're going to give two different groups in the room, or we're going to partition the room into groups A and B. And those groups are going to be given one of two case scenarios. An ethical dilemma you might see if you had a quantum company with a particular type of quantum technology. And the goal of this discussion is not, the ethics is a subjective thing. So we want to give you the opportunity to think of yourself as an actor, an ethical actor in your own research group, in your own career, where you have the power to actualize your individual values. And we want to use these workshops as an opportunity to develop what those are. All right, so to get ourselves started, to get ourselves a little loose, I want everybody to get out their computer or their phone and snap the QR code or enter in the address. We're going to do a little poll. And I don't actually know how Mentimeter works, so Sarah is going to help us make sure that we can see your responses. Enter in a couple of words that first come to mind when you think of the term quantum ethics. What do you think of? What does that mean to you? We got 3 responses so far. Hoping to get that number going up. I think we've got maybe 10, 15 people in the room. 10, maybe we show the results. People can still keep answering. RSA, encryption, that's a good one. Far away, hype, ooh, that's a really good one. Profit, military, don't kill people, that's perfect. That's a core value I think we can all agree on. Let's not kill anybody. Yeah, famous Google. Moral behavior, correctness, capitalism, inclusivity. Equity, that's a great one. Regulations. Oh, this is fabulous. See, y'all don't need our help. You already have the right idea. Privacy. Wealth distribution, we're gonna talk about that in a little bit. Industry. I love it. Okay. And we're going to come back to this. Mentimeter is going to be our friend. We're going to come back to these sorts of questions. But I wanted this to be a nice opportunity for you to remember that this is an interactive discipline. It's not a discipline where I'm just going to stand here and hand you the answers or the correct way to think about this. You have the correct way to think about this, and so does everybody else. Okay, can I get back to my slides, please, Sarah? Thank you so much. All right, so first off, let's define what quantum ethics is. This is my definition. I think it's a good working one. Quantum ethics is the field of study concerned with the social, economic, and political implications of quantum tech. And if you talked about ethics as a philosophical discipline, there would be quite a lot to talk about. That's not what I'm here to discuss. At the Quantum Ethics Project, we take a particular apply a particular set of values, where our goal at the Quantum Ethics Project is to ensure that this tech is used for the greatest and keyword, somebody put it in the word cloud, most equitable public good. In order to understand this impact, though, somebody else put hype onto that word salad there. This is really key, because we have to understand, key term, the credible applications of quantum technology. Because not all of quantum technology is born equal. Some pieces of quantum technology are considered by the community to be less feasible than others. And if we just naively picked any particular technology we could find and tried to talk about its social impact, we may be contributing to hype, because that technology may not in fact be useful. And this is an interesting research question that I'll get back to in my own work. where if you want to understand the social impact, a prerequisite is understanding the hype, or inversely, credibility of that application. And I love this quote. Matthias Schroer, if anybody's aware of him, he's recently founded a European quantum ethics institute called the Open Quantum Institute. And he gave this fabulous quote in the panel discussion outlining the mandate of his new project, where he said something similar about hype. He said that when we understand the social impacts of quantum technology, that this is the moment where hype gives way to clarity. Or I like to rephrase it, where hype gives way to credibility. And as quantum technologists, the only currency we have is credibility. So hopefully this motivates why this is such an important discipline. So y'all are probably already aware of this, but quantum technology separates itself into three main pillars: communications, computing, and sensing. Today we're going to focus on computing, because I don't know anything about the other two. And we're going to talk about the various impacts that quantum computers might make, whether that's machine learning, breaking encryption. People had RSA, that was your first thought. We've been talking about quantum ethics for as long as quantum has been around, because for the past 30 years, the only major application that's driven all the investment has been cyber terrorism through Shor's algorithm, right? This is problematic. But there's better applications too. Drug discovery. I don't know anybody else who may have mental illness, but I take medications every day, and if my meds gave me fewer side effects, I'd want that. Finance, could be some sticky questions related to that. Chemistry, one of the most promising in my view. Logistics, often cited. I haven't found a lot of good sources for that though. I think it's mostly annealers who talk about logistics. So with quantum computing, there's a timeline about when these various applications may be viable. Today, we can't do anything. Like factor 15 maybe. But if you want to do anything big, anything long-term, you're going to have too much problem with noise, and we're really looking in the 5 to 15-year range for when we might actually see quantum computers deliver their first useful quantum advantage. That's the regime that I work in. That's my research area. But lots of people who work on error correction, they're looking ahead maybe 30 years from now to the day when we could have fault tolerance. So when we're talking about these applications, let's separate them into their time buckets. How soon might we see encryption broken? 30 years. How soon might we see drug discovery or finance? Maybe soon. This is the area that I work in. So let me give you an example of research that I'm conducting for quantum ethics, and that is in quantum machine learning. Specifically, my specialty is in variational quantum algorithms. So this is the title slide that I presented over Reading Week. I was in Arizona presenting for the Center for Quantum Networks, which has just made me a Quantum Society Fellow, to do a research project related to assessing the societal impact of variational quantum algorithms. Just a real quick overview. If you're not familiar with what a VQA is, it starts with a classical computer, which is running some sort of optimization scheme. It hands a set of parameters to a quantum circuit, which is defined by those parameters. It tells you essentially the computer, classical computer tells the quantum computer which circuit to try next. The quantum computer then tries that circuit and tests to see how close we got to the objective that we are hoping to achieve. And that objective function is measured as some output of a cost, which is handed back to the classical computer, which runs some sort of gradient descent or point-based method optimization or machine learning to navigate this landscape and try and find the peak, the optimal circuit to run. With variational quantum algorithms, there are a lot of potential applications, and many in the community consider these to be some of the most promising candidates for advantage in the next 5 to 10 years. These applications are things like quantum chemistry with the variational quantum eigensolver. I think that's probably the one that's going to be the most familiar to folks. Portfolio optimization for finance or the hedge fund industry. Condensed matter. The VQSD algorithm was my first contribution to this area before I was a grad student. When we're talking about these applications, we need to understand how credible they are. This is going to be a big part of my project, and there's actually a couple of folks in the audience who are going to be collaborating with me on a research project next term to try and evaluate the credibility of all 60 of these. But for now, let's take the two most popular, chemistry and portfolio optimization. And when I say popular, I mean there are entire $100 million plus startups set up to implement one or the other of these. VQE is trying to be implemented by Qnesis, which wants to know how do we use this algorithm to simulate molecular Hamiltonians. And Zork wants to use the Quawa algorithm to optimize the hedge fund portfolios or the portfolios of wealthy individuals to make them more money on the stock market. Now, here's our first kind of example of an ethical dilemma. Google has been making headlines since like 2019 for its hardware. And let's imagine a world where Google is the owner of the first computer that can run one of these two applications. You've got a finite amount of time you can run one of these applications on, and you're a company that's invested hundreds and hundreds of millions of dollars in getting this computer to work. And companies have a legally binding fiduciary responsibility to maximize investment for their shareholders. This is not a negotiable thing. This is how companies are legally obligated to behave. So now think to yourself, if you have the hedge fund industry, which in the United States comprises nearly $4 trillion, and the advanced materials industry, which is maybe $40 billion, and quantum will be some subset of this, which industry do you think is winning a bidding war for who gets to use that quantum computer?
Hedge funds.
Hedge funds. So what have we just done? We have just spent all of our time, all of our creativity, all of our brilliance, and all of our resources building something. And the question I want you all to think about is, who are we building it for? Who is most likely to benefit from these computers, from this technology that we're making? Is it going to be my folks back home, the low-income rural community that I grew up in the US? Or is it going to be Jeff Bezos? All right, we're going to go back onto Mentimeter. If you're still logged in, it should still work. We're going to do the same question over again, yeah? All right, so we're going to clear the word salad from the first time we did this. Doop, doop, doop. Bear with us here. Does anybody not have the QR code? Does anybody still need it?
I went to the next question and it took away this part.
Ah, okay.
That's all good. Okay, it's been reset.
Okay. Or do we want to ask them question 2? Just like the same first question that we asked?
Right. Sorry.
You're good. Same question again. But I want to see, I'd be interested to see if the words change.
Oh, I'll try some Bezos. I like that. Hedge.
Yeah, I have a.
Some of us have a different question when we go to it.
Okay.
Go to slide.
Yeah, it might prompt you. You might get the question from the end.
Oh, refreshing work?
Yeah, if you refresh.
Yeah.
Sorry
Perfect.
about that.
Thanks.
Technology. Nice. Yeah, and these sorts of frames of thinking are not natural for folks like us in the programs that we're in. I haven't had any economics training. I've got a co-advisor now who's an economist who's going to help me flesh some of this stuff out more rigorously, but thinking about this technology that you're making and then how it's going to interact with the economy that it lives in is something that we need to work on intentionally to cultivate a way of thinking about this so that ideally, as researchers, we can design our ideas, our technology, with that great public good in mind from the get-go. Near term versus long term. Growing disparity. Monopoly, that's an interesting one. How many big quantum companies are there? Like 2? IBM and Google, and then a handful of smaller ones? Maybe Honeywell also? And how are those companies going to choose to use the technology? Yeah. Okay. Good. I like this.